Okay, the next example I want to take you through with the this remote control example, this actually comes right out of one of our training classes, the surfacing class, as a matter of fact. And this is going to show the technique of being able to take two-dimensional images, so something that maybe you drew out in some digital illustration tools, or maybe just on traditional paper and scanned it in, and how you can get from that really free-flow of ideas into the CAD system and use that as a launching point into your production parts. There's some more advanced surface modeling. You saw me just a little while ago just use one real simple surfacing command. We'll explore a little bit more of this. And also this touches into something that's really popular with a lot of consumer products processes, which is called the master model technique. And kind of did that with the coffee maker. I just designed it as one big blob to get the concepts figured out. Obviously, we're going to have to manufacture that with lots of different piece parts. So having, again, a nice transition from that 3D concept into the real production parts, with all the accommodations for the machine design that goes on the inside especially. So, so this example, I'll take you through sort of longhand just a little bit at the very beginning, but mostly I'm just going to walk you through the steps as they've already been done, just because we've only got so much time together today. But I did want to at least illustrate this technique and some of the tools available for you. All right, so I've got here a couple of 2D images. Artistic renderings, quick pencil sketches of watercolors here with an idea for what this remote control is supposed to look like. All right, so we want to take these ideas and bring them into our CAD system and use that as a launching point into some 3D design. All right, and I'm going to sort of cheat and jump to the one that's already been done. Okay, so this is how it might look in 3D. And what's really great about this shape is, number one, you can rotate it around and look at it from more than just two directions. All right, so this is going to allow the artist to make sure that his concept has really been captured. Number two, this is a real CAD model, meaning you can make a prototype from this. You can send it to one of our printers. And that is one of the major drivers that we have out there in our customer base for moving the industrial design type of things into a SolidWorks environment and get them to learn some of these tools and techniques, is so you can generate those models from the printers and other rapid prototyping types of technologies. So how is this done? Let's back up to the very beginning. All right, and just give me an empty sheet of paper again. And I'm going to start with just an empty sketch, just like I did before, like you saw me do with the coffee maker. And we're going to come up here and decide to bring in a picture for that sketch. And I might pull in this side view here. And you'll see that it instantly drops that TIFF file, in this case, into my CAD environment. And I can scale that around as much as I want and slide it and move it and rotate it. Typically, the next step that you want to do is to get the sizing down to something meaningful. So you might go ahead and measure this out. And maybe we know that this has got to be about 5 inches long. All right, so draw a little 5-inch long or 127 millimeter long guideline, and then scale this down to fit and sort of get an idea here of how that might then fit in with my CAD environment. All right, so just doing that rather quickly. Let's say we're going to land it right about there. Okay, the next step would then be to create some CAD geometry around this. And an industrial designer that I met several years ago told me that he always starts from the edges. He designs from the parting line in the edges, and you can see that the artist here has illustrated the edges, especially if we look at the top view of that. So I can then very quickly start sketching here and maybe just pick out a couple of lines and arcs and sketch out about where I want that parting line to go. Let's just kind of eyeball that pretty good, about like so. Right, and then from that, I can then intersect that or develop that with the top view. Right, which, for the sake of time, let me just fast forward to where the top view has already been brought in. Positioned in a different spot, of course. All right, and we'll hide this, and we'll show this one. All right, so here's the side and the top having been brought in together. All right, and you can then take and look at this from a top orientation, and again, start your sketching. So pick up some spline tools again, and sketch out how you want this particular shape to look. And very quickly come in here and kind of modify this to match the picture that you want to see. All right, so capturing that from the top and the side, we can then put those two ideas together with a couple of different techniques, one of which is to extrude out a surface. Let me show this. All right, so there's my parting line built out as a surface, and then from the top view, I can go and then trim that surface to match the shape that I sketched from the top. And let me go ahead and hide those input sketches now, and you can see where we've developed that 3D edge. All right, so the next step then, maybe let's build across the bottom. Let me start another sketch here, and let me just show this from the side and really quickly just grab sort of what this shape might look like here.
Yeah, a lot of engineers are kind of sometimes scared to work with splines. I know I was at the beginning, but having that sketch there really lets you focus on something with your spline. You're not just splining out in space.
All right, so we'll put that right about there. So, all right, just to quickly again give you the idea of how this approach would work. And then we're into creating some surfaces. So I might, for example, grab this edge and this edge and construct some surfaces between them. I may have missed. Let me back up a bit. This is the feasibility part of it. Is to make sure that I've got this built up right in the right spot here. Looks pretty good. Do a lock instead. And why am I not seeing this? Make sure the ends are actually on the ends. Go fast and make mistakes. That's what my algebra teacher used to always tell me to do. Last time, otherwise I'll just fast forward. From here, down to here. It doesn't want to give it to me today. Fourth time's a charm. We'll try one more secret technique here.
Yeah, no, there's a lot of different ways to try this. So I was wondering when you were going to pull the 3D sketches out.
All right, doesn't want to do it. Fine. I don't know what I did differently this time. Hey, here's an example. All right, so you can see building out a couple of these sketches. We can then generate the surfaces where they match in between. All right, so this is, of course, a slightly different spline that was drawn. But building out the surfaces, similar to what you saw me do before. Round off the corner, and then you're pretty much done. Reflect that to the other side, cap off the top, and you can go and print this and see how it feels in your hand. All right, so that was the example I wanted to take you through the remote control. That master model part then becomes a launching point that you can take into other designs. So let me go ahead and open up the example of that assembly. All right, so you can see now from that one part, I can then slice off the top of it and develop the inside of it into some other shapes. And do the engineering of how we're actually going to fit this together and how these little guys are going to lock into each other.